Welcome to day 48 of our school year. Get that in. All right. So our beginning fraction, our denominator is 180 because we have a total of 180 school days. We are on day 48. Let's find the factors of our numerator, 48. Two factors we always know are 1 and the number itself, using the commutative property of multiplication, 48 times 1. Now we want to check for any other possible factors using our divisibility rules. We're going to go in an orderly fashion. So we're going to go in order. After 1 in order is 2. So the rule for 2 is that it ends in an even number. It does end in an even number, so 2 is a factor. 2 times 24, 24 times 2. Now we're going to try 3. The rule for 3 is that we add the digits together. 4 plus 8 is 12. 12 is a multiple of 3, so 3 is a factor. 3 times 16, 16 times 3. Now we try 4. One way to check for 4 is to see if the second factor with 2 is even. It is. Also 4 times 12 makes 48. 12 times 4. Now we try 5. The rule for 5 is that it ends in a 0 or 5. It ends in an 8, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. They are both factors, so 6 is a factor. 6 times 8, 8 times 6. Okay, the only counting or natural number between 6 and 8 is 7. Let's try 7. 7, 14, 21, 28, 35, 42, 49. 48 is not in that list, so 7 is not a factor. Let's go ahead and list our factors from least to greatest. 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Is this prime or composite? Well, let's see. I have 2, 4, 6, 8, 10 factors. That is more than 2 factors, so it is composite. Okay, we want to find our greatest common factor. So let's start with 48 and see if that works. Remember, your groups do not have to look like mine, but they do need to have 48 in each group. And the shaded needs to be in a completely separate box from the unshaded. So here I have 2 plus 10, 20, 30, 40. So it's 42 plus 6 more make 48. So if you notice, I don't count. I know 6 and 4 make 10. So I just go all the way till I see 4 left over. So I use those 10s to help me out. What decomposes to make 10? So 4 plus 40 is 44. And to get to 48, I need 4 more. And then I'm left with 36. So that means 48 did not work. So let's go ahead and try 24. So I have 20 plus 4. And then 6 plus 10 is 16, plus 8 is 24. So you want to make sure that your shaded is in their own groups. There shouldn't be any shaded with unshaded. But your groups of 24 definitely may look different than mine. So 2 plus 20, 22 plus 2 more is 24. 8 plus 10 is 18, plus 6 is 24. 4 plus 20 is 24. 20 plus 4 is 24. 6 plus 10 is 16, plus 8 is 24, and I have 12 left over. So 24 did not work. All right, let's try 16. 10 plus 6 is 16. 4 plus 10 plus 2 is 16. 8 plus 8 is 16. So make sure you do your groups of 16 in just the shaded area, and then we check in our unshaded. Your groups do not have to look like mine, but they do need to have 16 in each group. So 2 plus 10 is 12, plus 4 is 16. 6 plus 10 is 16. Okay, I'm going to do 2 groups of 8. Because I know 2 times 8 is 16. Two, 4, 6, 8. Oops, I need 16. 2, 4, 6, 8, 10, 12, 14, 16. So I have 4 left over. That means 16 did not work. Let's try groups of 12. You want to make sure you keep your shaded separated from your unshaded in this grouping, but make sure there's 12 in each group. Okay. 2 plus 10 is 12. I'm going to four plus 6 is 10, so I'm going to cut off 4s because I know 2 groups of 6 is 12. To see how when we understand our multiples, breaking things down, it can make things a little bit easier. 4 times 4 is 16. I'm sorry, I don't want 16, I want 12. 4 times 3 is 12. 4 times 3 is 12. So when we understand, we're basically making arrays here, different arrays of our multiples. And it helps us get our groups done more quickly. So that one finally worked. Our greatest common factor is 12. So let's go ahead and count up our total amount of factors. 1, 2, 3. I'm sorry, total amount of groups of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 total groups, and we have 1, 2, 3, 4 shaded in. Okay, so now that we've done our division with our model, let's go ahead and do it with our algorithm. We're dividing into groups of 12. Okay, 48 divided, 180s first. Divided by 12, and 48 divided by 12. Let's see. I do 10, because when I multiply by 10, everything moves over a place. The tens place moves to the hundreds, the ones place moves to the tens, and I have my placeholder, because every place is 10 times greater to the left. Numbers the same, zeros a game, more on top, no need to stop. Numbers the same, zeros a game. Let's try 2 groups of 12. 2 times 12 is 24. More on the floor. Go next door. Regroup 10 more. 10 take away 4 is 6. 5 take away 2 is 3. 3 times 12 is 36. Numbers the same, zeros the game. Okay, over here, 2 times 12 is 24. Oh, I forgot to add up my partial quotients over here. 10, 11, 12, 13, 14, 15. You want to make sure you do that. More on top, no need to stop. More on top, no need to stop. Oh, and that's 2 times 12, which is 24. Numbers the same, zeros a game. Add your partial quotients. 2 plus 2 is 4. Now we need to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Well, I have the remainder of 0 for both. So that means, based on the identity property of addition, that if I add the 0, it's going to stay the same. So I'm not going to worry about adding 0. I have a 2-digit by 2-digit multiplication. So I'm going to do this time my expanded algorithm. And then over here, I'll just do my 4 times 12. Because I believe last time I did the area model. So 2 groups of 5, and then 2 groups of 10. 10 groups of 5, and 10 groups of 10. 2 times 5 is 10. 2 times 10 is 20. 10 times 5 is 50. And 10 times 10 is 100. Add up our partial products. I get 0. 1, 2, 3, plus 5 is 8, and 1. 4 times 2 is 8. 4 times 1 is 4. 4 groups of 1. You will never see with a 2-digit by 2-digit that doesn't have a 0 in it something that looks like this when you're done. There will always be a step of addition when you're dealing with 2-digit by 2-digit multipliers. All right, so 48 matches 48. Check. 180 matches 180. Check. So 4 is definitely our numerator, and 15 is our denominator. Now let's go ahead and fill in our data collection page. Okay, we're still in trimester 1, week 11. Today is 10, 16, 19. Our fraction for today is 4/15. Let's go ahead and get out our number line. We did groups of 12. So find our groups of 12. We have 1/15. We have 2/15. Now we need to get down 3/15. That has an equivalent fraction with 1/5 1/5 was the simplest form because you could divide both of these by 3. It's also equivalent to 6/30ths. Multiply both these by 2. 9/45ths. Multiply both these by 3. 12/60ths. 18/90ths. And then our beginning fraction, 36/100. I'm sorry. Is that right? Yep, 40/180ths. I knew that wasn't right. All right. So today we need to also get down 4/15ths. There's no equivalent fraction below, no line below, because this is our simplest form, or equivalent fraction in lowest terms. But there is an equivalent fraction in the 6's. 6 is a common factor. In the 4's, 4 is a common factor. In the 3's and the 2's. All right, let's go ahead and put your number line away, erase your worksheet, and thank you for joining me.